Good afternoon or good evening to you. We're going to take a look at concept 8, which is pressure. So for those of you who are taking a look at some digital notes online, there are Google Slides attached for you guys. So let's jump right into it. Okay, pressure. Pressure is the force applied to a certain area. So here I have a picture for you guys to take a look at. So we have a force that's being pushed down over a certain area, and then the result of that is pressure. Remember, fluids like solids and gases can be put under pressure or compressed because of the spaces between these particles. So here we have a gas. We can see these little circles that represent particles, and if we put pressure down, we can actually compress these particles. Okay, so all that empty space can be compressed. Liquids do not compress as much as gases, and solids compress less than gases and liquids typically. Okay, so there are some demos for you guys. In the past, what I've done is I've had, a bottle of Pepsi or Bepsi or Coca-Cola, and then what we do is we typically have these two bottles, and with one we have a small opening in the cap, and then the other one we have a normal size opening. We add Mentos, and we usually add the same amount of Mentos to each bottle, and we observe how the opening of that bottle changes the amount of pressure. Okay, so this is something you guys could do at home or at school. You grab two Coke bottles. One of them you could have no lid or no cap, and then the other one, what you could do is you could just drill a little hole in the top. Okay, how does changing the force affect the pressure? So again, what we can do now is we can change the amount of Mentos that we add to each Coke bottle. We can add more, we can add less, and then from there we can see how that changes things. Okay, pressure, force, and area demos. On Google Classroom, I'll post some videos for you guys. But what you guys can do is you can actually look at videos of people who walk on eggs, right? So you can see that with the amount of eggs that we have, eggs are pretty strong based on their shape. So we can try standing on eggs. If you guys have eggs at school, what you can do is you can get two cartons of eggs. So each carton of eggs has 24 eggs, sorry, has 12 eggs. And then from there, you can stand on them and see, can you stand on 4 eggs? Can you stand on 8 eggs? And then if not, you should be able to stand on 12 eggs. Okay, so what are the major takeaways? What do you need to understand for pressure and area? Well, as you decrease the area, you actually increase the amount of pressure. And then for pressure and force, well, if you increase the force, you're also going to increase the pressure. Okay. Here's the equation that you guys need to know. Usually on a quiz, you'll be given the formula. So your P represents your pressure. Your pressure is usually measured in PA, which is pascals, or it's measured in newtons per meter squared. Your F represents your force, and your force is measured in newtons or in N. And the reason why it's called newtons is because Sir Isaac Newton calculated that a newton was the amount of force that an apple had when it fell. So there's a story behind that. The A represents area, and then that could be in meters squared, centimeters squared, or millimeters squared. Okay, so let's take a look at some practice questions. So I'm going to exit out of here so that I can draw for you guys. So here we go. So we know pressure is equal to force divided by area. So here we go. And we are going to start drawing. So calculating the pressure. Here we're going to look at what we know and what we don't know. So we have 34 newtons. That's going to be a force. So that's 34. That's kind of messy. Let's erase that. So 34 newtons. Okay, and now let's look at our, what else do we have? Oh, we have an area, right? Meters squared. So area, and you should be trying to do these on your own as well. 7 meters squared. Sorry. And now the question is asking how much pressure? How much pressure? So we don't know P. Okay, so what we do is now we substitute that into our equation. Pressure is equal to force divided by area. So our force is 34 newtons divided by our area, which is 7 meters squared. Pressure is equal to, get your calculator, 34 divided by 7 is, I think it was 4.8, sorry, 4.857, so we'll just say 4.9, just round it there, 4.9 Newton meters squared. I'm sorry about that. Okay, so that's how we calculate pressure for the first example. Let's look at another example. Okay, so try these yourself. So I'm going to go through these as well. So here we go. 5 meters squared, that's an area. I'm just going to go through all of them. Okay, this one does not have an area. Okay, next one, this has an area. Okay, Daisy stands on a platform, that's area. That's an area. Okay, and this might be an area. Okay. All right. You press on a 5 meter square door with this much force, 340 newtons of force. How much pressure? Okay, so pressure is equal to force, which is 340, 340 newtons divided by 5. Okay, so we get our calculator. 340 divided by 5 gives us a pressure of 68. So we have 68. And our units are Newton meters squared. Okay, now we'll look at question 2. Bob pulls a rope with 560 newtons of force, and Danny pulls a rope with 340 newtons of force. How is putting, it shouldn't be how, it should be who. Who is putting more pressure on the rope and why? Well, let's go back to our example. So if we go back to our notes, if you increase your force, you're increasing the pressure. Those are our major takeaways. If we increase the force, we're increasing the pressure. So let's go back here. Who is putting in more force? Well, Bob is putting 560 newtons of force. Danny is only putting 340. Therefore, Bob is putting more pressure on the rope. Okay, so that's why Bob is putting more force down. Okay, question 3. Daisy stands on one platform that is 1 meter square and the other platform that is 15 meters square. When does she place more pressure? Does she push more pressure on the 1 meter square platform or the 15 meter square platform? Explain why. Okay, well, let's go back. Looking at pressure versus area. As you decrease the area, you increase the pressure. So if you decrease the area, you increase the pressure. The example that I like to think of is a nail. Like a nail tip is sharp. It's an extremely small area. But if you were to use that nail tip on like a piece of wood, it applies a lot of pressure with a hammer. So where does she put more pressure? Well, she puts more pressure on the 1 meter square platform compared to the 15-meter square platform because it's a significantly smaller area. So this is where she puts most of her area, sorry, her pressure. Okay. Pascal's law. Okay, so we'll take a look at Pascal's law. Now let's go back to here to your notes. Okay, Pascal's law. Pressure applied to a fluid in a closed system will be transmitted throughout the entire fluid at the same strength. So here we have different pistons. We have a piston A or some sort of, syringe or pressure unit. And we can see that it has a small surface area, right? Piston B or syringe B has a larger surface area. So if we apply pressure or force to piston A, because this is a fluid and it does not compress easily, it's going to have the same amount of force throughout the fluid, and therefore it's going to impact or put that force onto piston B. So where you would see this would actually be like, for example, a car brake system. So you put your foot down on the brake pedal, and then in our brake system, we have brake fluid, right? That brake fluid does not compress easily. So when you push on that brake pedal, that brake fluid goes through the master cylinder, and then that fluid gets pumped through your brake lines, and then it goes to your actual calipers, and your calipers then put that force on your brake pads, and then the brake pads then squeeze your actual rotors, which cause you to stop. Okay, so that's a tangible example of how this works. Another example would be, for example, if you've worked on a car and you've used a jack. So Pascal's law, if you apply pressure to that jack by pumping that jack, you're building up the pressure. Well, then that pressure then puts that force on the actual jack lift area so that you're able to lift that car up. This is with a hydraulic or a pneumatic jack, not the ones that you kind of just screw and turn. Okay. Another example, when you squeeze the end of a toothpaste tube, the pressure is transmitted throughout the tube. And if the lid is on, if the lid is off, then the toothpaste is forced out, right? So we all know we're all trying to get that last bit of toothpaste out. So what we can do is we can kind of roll that end of that toothpaste, and that then increases the amount of force that's applied to the toothpaste in the tube, which then squeezes it out so that we're able to get every last drop. Okay, and that's it for pressure. If you need any extra resources or you have any questions, feel free to reach out. You can reach out to myself, reach out to Brian, let me know, and I am more than willing to give you guys some examples of what you can do in class. Um, I'm not sure what your school supplies are, but it's always nice to go to like a pharmacy and potentially pick up some syringes. You can typically get like those baby syringes and you can hook them up with uh, bubbler, air filter, plastic lines, and you can kind of play with different fluids from there. Have a good evening and bye for now.